topic left for this unit. This last topic is actually going to be broken up into 2 different videos. The first video, I'm going to talk about just predicting the products. And then the second video, I'm going to talk about predicting the state of matter of the products that we're predicting. This video, I'm going to warn you now, it's probably going to end up pretty long, but that is because I'm going to do a lot of different examples on these just so you can see the process. If you were in class, you know that we pretty much did examples all day long because predicting products is a pretty crucial skill, and until you get the process down, a lot of times you have to see it a few times just to kind of comprehend what's happening here. So with my examples that I'm going to do, I have several different types. We're going to go through the rules on how to predict a synthesis reaction or how to predict a single replacement reaction on all those different types. And then at the end of the video, I'm going to run through, I think I have 8 or 10 different examples. If you don't want to stick around for all the examples, if you think you got it down, that's awesome. If you want to kind of bounce back and forth, that's fine too. The second part of the video, I'm going to take the examples that I'm going to do on the document camera here, and we're going to apply another set of rules where we can actually predict the state of matter of the products. But I want to break it up into 2 different videos just so that way you can see the process on each of them. So when we look at these in class, we're going to do predicting products one day, we're going to do predicting state of matter, and then we're going to put it all together for one assignment. So looking at these different types of reactions, remember there are 5 different types of chemical reactions. You're not going to have to predict a decomposition reaction. For the scope of this class being pre-AP chemistry, you don't have to worry about predicting those, but we will have to predict all the other types. So we're going to have to identify the type of reaction that we have first, and then after we identify the type of reaction, then we're going to follow these different rules. So in a synthesis type reaction, remember you're making one compound in the end. So if you have a synthesis reaction that you're making one compound in the end, all that you're going to do is you're going to find your 2 elements that are coming together. They're all going to be ionic. You will not have to predict a covalent compound, sorry. So you're going to have 2 different elements. You're going to combine them together and swap and drop. So if you see something that has just 2 individual elements, make sure you have your cation first and then your anion. Look up the charges, swap them, and drop them like we've been doing with all the nomenclature. Single replacement reactions. These you're going to see a single element with a formula or a compound. When you have a single element with a compound, you're going to have to remember that you have a cation that has to replace a cation, or an anion replacing an anion. And when I go through the examples, I'm going to show you kind of a T-chart that I use to do these a little bit easier, just so you can keep track of everything that's happening. But you'll always have a single element before the arrow and a single element after the arrow. Just remember that your single element might be in Brinkelhoff, so it might be a diatomic element. Double replacement reactions. You have 2 compounds before the arrow, 2 compounds after the arrow. You're just going to take your cations and trade their places, or their anions and trade their places, and you have to re-swap and drop. So with these, again, we're going to use a T-chart because a lot of times that is helpful. Combustion reactions are super easy to predict your products because you only have 2, and they are always the same. So if it asks you to predict the products on a combustion reaction, it is just CO2 plus H2O. Or if you want to get crazy, you can put H2O plus CO2. It's the same thing. But you have just those 2 products, CO2 and H2O. All right, so for these examples, I have my document camera, like I said. I have 8 or 10 different examples, and I'm just going to run through all of them using these rules that I just talked about. If you get bored, you can fast forward. If you're good with doing these, you can go ahead and do your assignment. Whatever you want to do, that is up to you. But I just wanted to run through several examples because some of you guys are at home instead of here, and I know that this is getting a little bit more difficult. But this is a skill that you're going to need second semester because in the lab it's going to say, hey, we're dealing with calcium carbonate and hydrochloric acid. It's going to put numbers with these. It's going to say, hey, you have 4 grams of this and you have 2 liters of this. How much product are you going to make? It doesn't even tell you what product you're making. So you're going to have to take these 2, predict your products, and then do the math. So if your nomenclature is real weak, you're going to struggle. If your balancing equations is weak, same thing. So you have to make sure that you know all these skills moving into second semester when we take it and we apply it to all of the math. So with this one, I have CeaCO3, calcium carbonate, and hydrochloric acid. We have to predict our products. This is a double replacement reaction. I know it's a double replacement reaction because I have two compounds before the arrow, which means that after I'm going to have two compounds. When you go to predict your products, this is the easiest way that I've ever found to do this. Make a T-chart. Your cations, your positive charges, are going to go on this side. Your anions are going to go on this side. You're going to unswap and drop. Undo whatever they have done. And you're going to write that, and you're going to break up each of the formulas. So CaCO3 I'm going to use on the top column here. So calcium is Ca. It has a +2 charge because it lives in group 2. And then CO3 is carbonate. It's CO3 -2. I just undid what they have here. I'm going to do the same thing for hydrochloric acid. I'm going to undo that. Hydrogen goes in the first box because your positive charges always go first. Chlorine goes in the next box. Hydrogen lives in group 1, chlorine's a halogen, it lives in group 17. So now what I'm going to do is I'm going to trade partners. I'm going to take calcium and pair it up with chlorine. I'm going to take hydrogen and pair it up with carbonate, and I'm going to re-swap and drop. So for my new products over here, I have CaCl2 plus H2CO3. So the 2 came over here, the 1 came over here, 2 came over here, the 1 came over here. So when you're predicting your products, you undo the swap and drop, and then you have to put them together in a new way. So we have to figure out the charges. So that's why I undid that, +2 -2, +1 -1, and then I just re-swapped and dropped with the new partners. The next one down here, this is a single replacement reaction. I know it's a single replacement reaction because I have a single element and I have a compound. Now here I had to give you extra information. Iron is a transition metal. With iron being a transition metal, it doesn't tell you the charge on the periodic table. It would have to tell you that in the reaction. So in this case, I told you that iron is iron 3, which means that iron has a +3 charge. So when I go to swap and drop that one, it's had a +3. Again, I'm going to use my T-chart. Positive charges go on this side, negative charges go on this side. Iron is a single element. It's Fe +3. There's nothing written over here because it's single. Then I'm going to undo the copper 2 sulfate. So the CuSO4, SO4 is a polyatomic ion. SO4 is SO4 -2, which means that copper is +2 because it has to cancel out and equal 0. Now I'm going to trade partners. Iron is going to pair up with sulfate. Copper doesn't have anything to pair with. So with that one, copper is going to be my single element. And then Fe2, SO4, 3. So I undid the swap and drop, wrote it down here, and then I re-swapped and dropped. Okay, next one. I have H2 plus N2. Both of these are single elements. With both of these being single elements, I have hydrogen and I have nitrogen. Hydrogen has a +1 charge. Nitrogen has a -3. I have to write my formulas when I swap and drop with a cation and then an anion. You can't switch that. You can't put 2 positives, 2 negatives, or anything like that. So we just had to switch it like that. So if for my final formula over here, I'm going to swap and drop. I have to make sure that my positive charge is first, which it is. So I would have H3N, hydronitric acid. The next one down here, this is another double replacement reaction. For my double replacement reaction, I have magnesium chloride and calcium phosphate. So magnesium is +2, chlorine's -1. I have calcium +2, Phosphate is PO4 minus 3. Again, I'm just undoing what they're swapping and dropping with. I'm going to get my new partners, magnesium with phosphate, Mg3, PO4, 2. And then I'm going to take calcium and pair it up with chlorine. So that one would just look like that. The next one, I have a word problem. This is normally how you're going to see them in the lab. If you have a word problem, we have to write out the formulas. So we have chromium 3, so we have chromium with a +3 charge. Chlorine is Cl minus 1, so we end up with CrCl3. Reacts with silver is +1, nitrate is NO3 minus 1, so AgNO3. Now I need to predict my products. Again, I'm going to undo my swap and drop. Cr +3, Cl minus 1. And then I have my Ag +1, NO3 minus 1. I'm going to trade partners. So I have my chromium that's going to pair up with nitrate. And then I'm going to take my silver and pair it up with chlorine. And I'm not balancing any of these again, just I'm saving time. All right, the next one, this is the last of the new types of compounds. After this one, if you think you have it, then you're good. If you want to keep sticking around, I've got a few more of these that I'll do as well. But this is a combustion reaction. We haven't seen a combustion reaction yet, but combustion reactions are super easy to predict the products. When you go to predict their products here, you make CO2 plus H2O. That, like I said, you can switch those if you want to, but otherwise you always make the same products. Now, something that I did forget to tell you at the beginning, when you're predicting your products, I don't care what order you write your products in. It doesn't matter. I had a college professor that made us write them in alphabetical order. So he would make the Ag one come first because silver is Ag, and then so A and C. He did that to make it easier to grade, but there's no rhyme or reason as to why they're written the way that they are. So if you wrote it as silver 1 chloride first, that's fine. It's up to you how you want to do that. All right, the next one, it says chlorine reacts with sodium bromide. Chlorine's a single element, reacts with NaBr, sodium's +1 minus 1. Chlorine, though, is in Brinkelhoff. It gets a 2. Make my Tchart. Chlorine is a single element. With chlorine being a single element, when it's on the periodic table, it's a halogen. It has a -1 charge. So it's Cl minus 1. Again, we're writing down the ions, not the formulas that are given. And then I have Na +1, Br minus 1. So when I go to make my new products here, those two are going to go together to make NaCl. Plus, bromine doesn't have anything to pair up with. That means that bromine is going to be my single element. With bromine being a single element, I don't write the negative because when we have a reaction like this, we don't have negatives or positives. But I do need to figure out, because it's a single element, is it in Brinkelhoff? Is it a diatomic element? Brinkelhoff starts with Br, so it gets a 2. All right, the next one says aluminum. Aluminum reacts with sulfuric acid. Ic means this used to be 8. Acid means you have hydrogen ions, so you have H2SO4 for that one. Sorry, my paper just went blank. There we go. We need to predict our products. This is another single replacement reaction because I have a single element. Make my Tchart. I have aluminum. Aluminum has a +3 charge, so it goes in the first box. Nothing over here because it's not paired up with an anion. I have hydrogen, which has +1. Sulfate is SO4 minus 2. So now I need to trade partners. Aluminum is going to pair up with sulfate, Al2, SO4, 3 plus, I don't know if I can squeeze this in or not, but my hydrogen doesn't have anything to pair up with. Ooh, sorry, I'm off the paper here. Hydrogen doesn't have anything to pair up with, so hydrogen is going to be my single element. So it just gets an H. We need to figure out if it's in Brinkelhoff or not, if it's a single element, which it is, so it gets a 2. All right, the next one, mercury 2. Mercury is Hg. It reacts with phosphorus, which is P. Now with this one, I have mercury and I have phosphorus. Those are both single elements, so this is going to be a synthesis reaction. We need to figure out what they make. Mercury has a +2 charge here. That's what that 2 tells me. Phosphorus is P minus 3. So again, I'm going to swap and drop Hg3, P2. Next one, we have ammonium iodide. Ammonium iodide is NH4I. Reacts with nitrogen gas, that's N2. Nitrogen is in Brinkelhoff, so it gets a 2. It does tell me the state of matter, so I'm going to have to tell the reader what it is. If I do my T-chart here, I have NH4 plus 1. I have iodine minus 1. Nitrogen, as a single element, is an anion. It has a -3 charge. So when I go to swap and drop here, my ammonium is going to pair up with my nitrogen. So NH4, 3N, plus my iodine is all by itself. So it just gets an I. Iodine is in Brinkelhoff, so it gets a 2. 2 more, and then I'll be totally done with this. Oh, one more. Sorry, one more. I lied. This one says lead 2 phosphate. So lead has a +2 charge, Pb, and then PO4. Phosphate is -3, lead is 2. Reacts with potassium, K plus 1. Chlorate is ClO3 minus 1. It's a polyatomic ion. So you have Pb3, PO4, 2, and then KClO3. We need to predict our products. Go back to my T-chart. Undo the swap and drop. This is a double replacement reaction. So I have lead with a +2 charge. Phosphate is PO4 minus 3. Potassium and chlorate. So currently these two are put together. With these two put together, I need to trade their partners. So I'm going to take lead and pair it up with chlorate, Pb, ClO3, 2. Plus, I need to take my potassium and pair it up with phosphate. So K3PO4, just like that. You also don't have to put that in parentheses if you don't want to. So I hope that that made sense after I did a few examples. If you still need anything, or if you have any questions, make sure that you ask. You can always email me or send me a message. Have a great day.